So this is a quick update to my Jupyter Notebook project development. The students are currently working on their first project about the Euler-Cromer method. That is due in just a few days from the time of this recording. It's due, let's see, from the day this launches, it's due in 2 days. So this goes up on a Wednesday, the assignment's due on a Friday. I've noticed a couple things that I would like to change about my assignments. I'm going to use this one as an example, and then I'll work on the others off camera. One is that my students, I handed them their force and initial conditions that I wanted them to use during class discussion. And what happened is they kind of took that as their instructions, skipped over the instructions in the template, and just kind of immediately started pasting the force in here, which is where I wanted them to run it with the spring force just to make sure they knew how to work the code. So they were kind of skipping over some of the instructions there, which students do, right? Once they think they know what the instructions are, they tend to go straight to the calculation. They identified the thing that they need to do. So I'm going to make a couple changes. One is I'm going to place the force in here. Your force, so for example, here I'd say your force is, your force and initial conditions, and initial conditions are, and then I would have, say, student name, then we can tab, well, this doesn't let you do tab, does it? Okay, student name, several spaces, we can tab the force, that can be kind of long sometimes. And then we'll have initial conditions. As for example, here I might have Bob, and Bob's force might be, let's see, I come up with a couple of these. One was x cubed minus x times exponential of negative x to the square times x hat, and they have to figure out how to implement that as a vector. And then initial conditions, position equal vector 0, 0, 0, and momentum equal vector 0.75, comma 0, comma 0. I think that was one of the combinations. At least it was pretty close to it. And then I might give one to Carol here. And let's just copy the number of spaces here. And let's see, another one I found that was neat. Was it a negative? I don't remember. Was it a negative? I think it was a negative. Cosine of x times sine of x. Yeah, that was a negative. And then we'll put in a bunch of spaces to get over to here. And this one's initial position was vector. Let's see, 0.2. Excuse me, 0, 0, 0. I was looking at the momentum instead. Comma space, momentum equals vector 0.2, comma 0, comma 0. Oh, and I forgot to put an x hat on here. Actually, I suppose there's no harm in going ahead and putting this in as a vector, just to help them out. You do a comma 0, comma 0. That was a logistical hurdle I hadn't anticipated. I mean, they figured it out, but, you know, you don't want them to be straining the brain on things that they don't necessarily need to be straining brain on. So there we've got our student name, our force, and our initial conditions. This way, I don't have to hand them a separate set of instructions. I can just say, go get the Euler-Cromer method project, and start with this. And actually looking at my notes, I see this is a 0.78 to ensure that that's a scattering state. The other thing I think I'll do to encourage them to read the directions is to actually assign the points to each learning objective, just so that when they see points, they'll know that that's something they need to look at. So let's see, I've got learning objective 1. How many learning objectives do I have? 1, 2, 3, 4, 5, and then 5 again. 100 does not divide up nicely by 6, so 100 divided by 6 is about 16 and some change. So let's make this 15 points. And then we'll make this one 15 points as well. And then this one is a little bit more intensive, so we'll make it 20 points. And then we'll make this one here 20 points. And then this one can be 15. So let's see, what do I have so far? I have 15, 35. 35 plus 20 is 55. 55 plus 15 is 60, 70. 70, 85. So I have 15 points left to go between, to go here. So that's fine. So this should be 15 points then. I don't know that I like the last part being 15 points. Seems like that should be more weighty. Yeah, I would like the discussions to both be 20 points. So let's make that one 20 points. Where else do I have a 20 pointer hanging out? 20, 20, 20. No, this one can be 15. Explain the use. Yeah, that one can be 15. Okay, let's do a little bit of checking here. 15 and 15 makes 30. Plus 15 makes 45. Plus 20 makes 65. 70, 80, plus another 20 makes 100. There we go. I think that'll help direct the students' attention to the learning objective so that they understand that this is, each of these is stuff that they need to do, as opposed to just jumping straight to the end to plug in the forces that they need. Let's see. Copy in class you've been assigned. So I need to say this. In the code cell below, you've been assigned a force to investigate. Paste the Euler-Cromer method above and modify it to replace spring force with the force. You know what? I haven't mentioned initial conditions here either. Oops. Find a force and a set of initial conditions. Paste in the Euler-Cromer method below and modify it to replace the spring force you were assigned. Spring force and initial conditions with the force and initial conditions you were assigned. There we go. Small change. I'll propagate that kind of change forward to the other assignments as well. And I'll update the template files that I've linked to just so you have the latest and best versions that I've developed so far. So thank you so much for watching. I will see you next time. Bye-bye.